All right, this is going to be a lot to squeeze into 5 minutes, so I'm going to go super fast. Find me later for questions because I'm not going to say everything I should say. I realize I'm starting off with a contentious statement here saying that there's a problem with object storage that we should solve. Let me try to convince you that this is in fact a problem and one that we should care about because cloud native has become effectively synonymous with data and object storage. I've been on a bit of a journey this summer with my colleague Signal. We've been writing a lot about raster formats. One key topic that came up was this idea of chunking. Chunking is a tool in data formats, not just raster formats, but all types of multidimensional data that relates to this idea of linearization. If you have multi-dimensions, you need to represent that data as a single dimension stream of bytes. So you have to linearize that data in some way to represent it within a computer. I spent a lot of time thinking about this idea of chunking. I made this cool tool, go play with it, it's fun, to try to understand how to make this more efficient. We have to use chunking because we have to get one-dimensional string of bytes. So it is a super useful thing, but it's also kind of tyrannical. Chunking misaligned with access patterns can cause significant data access inefficiencies. Big chunks you have read amplification, you get more data than you actually want, and that's slow. Small chunks fix that. Like, they fix that, but we can't use small chunks with object storage because it increases the number of read requests we have to make to get all of those chunks, and network latency cripples us. So let's talk about object storage. It's kind of like a file system where we map file names to data in a backing block device. But instead of one block device, we actually have this big distributed block store, like potentially millions of block devices, and our data gets split up across all of that. So we map these object keys to many different pieces inside this distributed block store, and we can read those in parallel to get higher performance. So let's consider like a cog, for example, in object storage. When we read a cog, at least with cloud native tooling, we don't read the whole thing. We read it chunk by chunk, right? We find the chunks we want and we read those. Did I say bytes? No, I said chunks. We don't care about bytes, right? We care about this logical array that the cog represents. And these chunks get spread out across this block store, and we can make parallel reads across this, right? So what if instead of having client-side tooling go through this whole object-based interface, we instead had a chunk store type API? I mentioned client-side tooling here. Let's look at what it does to read the data from a cog in some detail. Consider this array of chunks, 4 by 3. It's linearized into an object. We want to request this highlighted region. First, we fetch the metadata, and then once we have the metadata, we figure out the chunk layout, and we can then figure out what our query needs to be based on linearizing our two-dimensional slice into two single-dimensional slices within the linearized representation of that data. And once we have that, we can make HTTP requests for this too, though, right? And this is the problem with small chunks because we have to make even more requests for non-contiguous chunk ranges. So what about this chunk store idea? The real issue with object stores comes from this imposition of the object model on our multidimensional data access. Objects erroneously impose this linear byte-based interface on us. So I think it's worth asking, do we even need objects when it comes to data access? It shouldn't matter how the chunks are arranged within objects in the block store, but for reading that data, we can ditch the object API and use a multidimensional API that manages the mapping of our coordinate dimensions to those chunk bytes within the distributed block store. That's something clients are building up today, right? You fetch all that metadata and you build up this index and then you figure out what to request. Just push this server side and then the clients can make requests in coordinate dimensions to resolve n numbers of chunks. And if it's n numbers of chunks, then we can make chunks smaller without increasing our request count. I have a proposal for this. It's something I call the Coalesced Chunk Retrieval Protocol. This might not be the right answer, but I think we need to be thinking about what is the answer to this problem, and this is what I'm proposing. This is an example of a request. We don't care about bytes. We don't even care about chunks. We simply make a request with a slice in our coordinate dimensions. This looks really familiar, maybe. There's things that look like this, like web coverage services going way back, but the thing here is this is not a compute engine. It's just a byte broker. All it does is coordinate to chunk resolution to resolve what those chunks are and returns those untouched. It's like predicate push down in an API. I've published a rough draft of a spec as a starting point for discussion. It's not good, but I think the big pieces are there to start a conversation around this at ccrp.dev, and I think I'm out of time. So, thank you.